belong to the same turtle family. They all obey the same commands. By getting to know these turtles as they get to know a person, these children are learning to be mathematicians. This is Piaget's real message, learning rooted in experience.
Forward 60, right turn, forward 60 again. The turtle is giving the children a feeling for the properties of an angle. They experience an abstract concept.
Yeah. No. No.
The body-centered commands of Logo are closely related to the natural way we move. Children from Old Oak Primary, London, live close by Wormwood Scrubs. Their teacher takes them out onto the big space where they can walk out shapes. One child is pretending to be the turtle, the others give commands.
No, left, turn left. Left a bit. Yeah. Forward, 6, 5. Right, turn right. 2 paces. 2 paces, yeah. Nuts. Right a little bit. Left a bit. Left 1 pace. Left. Left. Yeah. Oh, come on. Hurry up.
The essential point about the turtle is its role as a transitional object. That is, a transitional between the body, the self, and abstract mathematical ideas. The turtle can be, you can identify with it, you can move your body in order to guess how to command the turtle. So it's related to you, to the body, to the human, and it's also related to mathematical ideas because its structure is such that it captures some extremely powerful geometric and physical ideas. Watch how this turtle moves and draws as it goes. At the heart of the geometry of physics is the combination of movements. The turtle has a retractable pen in the middle. When the wheels turn in opposite directions, the turtle rotates around the pen. When they turn in the same direction, it moves forwards and draws a line straight as an arrow. The wheels are driven by independent motors, which turn in unison at exactly the same speed. Of course, for this, the turtle must be built as a precision scientific instrument. Despite its appearance, it's no toy.
The maths room at Crabtree Primary was the first classroom in England to have a turtle. It encourages talk about maths. We all accept that we learn French easily in France, so why not maths in Mathsland? Learning is so much more difficult from a textbook. Pappard asks why half the population are maths phobics, afraid of numbers, woolly-headed about abstract concepts. Today, the girls are programming the turtle to draw dice. They've got the outline. Now they're experimenting with shapes. They're trying to decide what would be the best shape for the spots.
It's going to end up with a 10-sided shape. 10? Why? I don't know. It's not going to be a hexagon. It should be more sharp. Well, carry on. Yeah. Left, 9, 13, sorry. Space. And...
But how does the turtle help them with their maths? Teacher Beryl Maxwell.
The great thing is it does provide a mathematical environment for the children. And while the children are working around the turtle, if you listen to the things that they're talking about, it's all mathematical. And I think verbalization in mathematics is very important. And I think that half of our problems with mathematics teaching is because children don't communicate mathematically, talk about mathematics, and actually experience mathematical problems.
Oh no!
What were you intending to do then?
Determined to get a hexagon.
Oh, you want a hexagon?
Yes.
Why do you want a hexagon?
Because We want a hexagon from the dice.
We just want to see how we can get a hexagon, and then we're going to choose the best of these three shapes to put on our dice.
Oh, I see. Now, what shapes have you got? An octagon, a
Dodecagon.
now a hexagon.
But if this doesn't work, we'll probably use that one, depending on what this one turns out as. But what we're going to do is forward 4 and left 60. I want to try it.
Why do you want to try 60?
Bigger the angle, the less sides you have.
So now you're going back.
Yeah, we're going to try 60.
Right. So what instruction do you think you need to put into the turtle?
We need pen.
The teacher's role is really to stand back and assess when to interfere. I think that using the floor turtle has personally made me think very carefully about the questions I ask children, how I ask the questions, and when to ask the question.
So we'll go forward like 60. Yeah, we may as well do that. Look, this has got going in this direction. Yeah.
It's done what you thought it would. Good.
The children have no fear of maths. They've learnt the properties of angle by playing with shapes, and they've been thinking through their problem in a very natural way.
The turtle started because I wanted to find something which could be picked up by very young children. Now I think of it as something that is just as valuable for people of any age as for the very young children. And again, that's a general principle that what's good for thinking is good for thinking, whether we're a 5-year-old or a sophisticated scientist.
Research with severely handicapped children has helped us to understand the way all children think and learn. Children who've never played with any object can control floor turtles. Cotting School, Boston, welcomed a team of researchers from MIT to find out what concepts these children had built up without the experiences of building, pouring, sifting. Their strategy is explained by researcher Susan Jo Russell.
Because they're not mobile, they can't move themselves, they're dependent on adults or older children to move them around, is that they can't explore space. And so understanding how things fit together in the world and what behind means and what happens when something goes behind something else is something that they haven't had a lot of experience with. Here, they've got a little world in which they can control how something moves around in space.
I think we have a key stuck here. Send it right into Andy? Or are you going to go
Alex
back?
and Mickey, who are the two boys who are both non-vocal and have very impaired hand use, we see several things going on with them. One is that this provides an activity around which shared communication takes place, and that's extremely important for them. The second thing that we see with them, and if you could have seen them in the session before this, you would see the change. Getting to have more control over their hand use is something that we've noticed with several of the children. And Mickey had a very hard time at the beginning operating the button box, simply getting his hand to the button that he wanted to get to, and then getting his hand off when he wanted to stop pushing that button.
The button box is a simplified keyboard. In using it, the children are preparing themselves for programming. It gives them control over their environment, which has a terrific payoff.
Now what? Where you going?
Watching these children tackling the problem of how to knock the tower down gives us an idea of what is going on in their heads. For children like these have very little opportunity to express themselves or to share a new engaging activity. The computer environment releases trapped intelligence. It gives these children a way of not keeping everything in their heads,